Ladies and gentlemen, hello and welcome coming to you not quite live from One Take Studios. Today we are talking about solving systems of equations by substitution. And again, we're focusing specifically on linear equations today, but what we are doing today could be used for any kind of equation, quite frankly. Alright, so here's the thing. Our focus today is going to be having two different variables to solve for, but to do that, it's not really possible unless you also have two equations. So if I've got two variables and two equations, this actually makes it possible. How? How would I do this, you ask? Well, I'm going to show you four examples today. Each one is slightly different, and I picked them for a reason. So humor me, and I think you'll see it is worthwhile. So here's our first example of the day. This is my system of equations. The first equation is y equals 2x plus 1. The second equation is x plus y equals 4. So we're not talking about solving either one of these separately, but we're saying these guys, they're a joint package, right? Together, I want to find one solution for both of these. When we looked at solving systems by graphing, we realized that if we graph these, typically they cross at a point, and that point that they cross at, that's our solution. So today we're trying to say, how can I find that point without graphing? And this right here, ladies and gents, right here, this is it. Boom. This is our goal. Excuse me. We would like to replace a variable in one equation with a chunk of equal value from the other equation. This is easy to say, but not necessarily easy to understand unless you see what is happening. So if you look at what we've got here, my first equation has the y by itself. And this y equals 2x plus 1. So what I'm saying is that this chunk, the 2x plus 1 equals, is the same as y. So if I go to the other equation and I find the y and say, all right, what happens if I substitute? What happens if I replace this variable right here with this chunk right here? That's going to go there. So this equals y. This says y. I am replacing this y, this variable, with the chunk from the other equation that is of equal value. I'm hoping that makes some sense to you because you can't really ask me questions right now, which makes me sad, but let's look at how this would happen and see if it makes sense to you then. So this equation is x plus, but instead of y, when I go to write this equation, I'm going to put this chunk here in place of the y. So I'm going to write 2x plus 1 instead of writing y right here. I'm still going to write equals, and I'm still going to write 4. So what I've done is I've just rewritten this equation right here, but I took the y out and I put 2x plus 1 in its place. Why would I do such a thing? Well, again, if I've got two variables, it's really hard to solve. I can't figure out what one of them is if they're both present at the same time. Look at my new equation. It doesn't have two different variables anymore. They're both x's. No more y's. The y is gone. So the whole idea is if I can make it so that I only have one variable instead of two variables, now I can actually solve. So if I'm looking at this, this is 1x plus 2x. These are like terms. I can add those. 1x plus 2x is 3x plus 1 equals 4. And again, now I'm back to my solving. Undo what is around my x. So minus 1. That is gone. There's 3x is equal to 4 minus 1 is 3. And getting x by itself, undoing my multiplication with division, dividing by 3, x equals 1. All right. Am I celebrating? Am I done? Not quite. If you remember, these two lines, the solution is a point, one ordered pair that makes both of them true. I have half of an ordered pair. It's not quite enough. So I'm going to go back up. I can pick either one of these, but since I'm looking for a y value, I want to pick the first one. All right, so I'm just going to rewrite this here for a second. Y equals 2x plus 1. But what I'm going to say now is, hey, I know that x equals 1. So I'm going to take that 1, I'm going to put it right there. So this becomes y equals 2 times 1 plus 1. So replacing the x with the number 1 since I now know that the x equals 1. Which means this is y equals 1 times 2 is 2 plus 1 is 3. I now have an x, I have a y, I have a pair. Ladies and gents, my solution, the x is 1, the y is 3. That point right there is the solution to the system. That point works in the first equation. And if I put to the second equation, 1 plus 3 equals 4, I can see it works there as well. So this point works in both equations, and if I were to graph them, this is going to be the point where they intersect. So this is my answer. All right, and so this is what we mean by substitution then. Taking a chunk from one equation, putting it into the other equation, so that we can solve having one variable at a time, rather than try to deal with two variables at once. Okay, so that was one. I promised you 3 examples. Sorry, 4 examples. Sorry. Okay, so next up, why am I showing you this one? How is this one different from the last one? Well, there's 2 things that have changed here. In my original example, y was by itself, and I plugged in place of y. Well, this time x is by itself. Could I get y by itself? Yes, but why would I want to make my life more difficult? If x is by itself, I want to use this. I'm going to use this as my chunk. X is equal to y minus 7. So in the other equation, I'm going to find the x, which is right here, and I'm going to replace it with the y minus 7. So that's one thing that's different. The other thing that's different is this was 3 times x. Here, this was just a y sitting by itself. So this is going to change how I work with this as well. So not only am I going to put y minus 7 in place of x, but since 3 was being multiplied times x, I'm going to have to multiply 3 times my chunk as well. So what is that going to look like? Well, again, I'm going to write this equation, but I'm going to take the x out and put the chunk in its place. So 3 times, I'm going to use parentheses here because instead of x, I want to write y minus 7, and all of that is being multiplied times 3 because the x is being multiplied times 3. The rest of this equation is the same, so this is going to be minus 4y equals negative 23. So I've just rewritten this equation without the x, putting y minus 7 in its place. What can I do with this? Well, I'm hoping you're looking at this and saying, distributive property. Good, because then we'll distribute the 3, we'll distribute the 3. This is going to be 3y minus, well, 3 times 7 is 21, minus 4y equals negative 23. Again, look how much happier our world is because the x's are all gone and we just have the y value there instead. So again, if we can substitute, we can get it down to one variable so that we can solve. 3y minus 4y, those are like terms, they're on the same side. 3y minus 4y is negative 1y, minus 21 is equal to negative 23. And again, I'm working to get that y by itself, so let's undo the minus 21 with a plus 21 on both sides. Going, gone. That's still going to be a minus 1y equals negative 23 plus 21 should be negative 2. Y is almost by itself. Dividing by negative 1, dividing by negative 1, gone. There's my y by itself, happiness and joy. And negative 2 divided by negative 1 is positive 2. Should I rejoice? Are you focused? Did you catch it? Again, we're not done. Having one number is not enough. We need a pair of numbers, a point, an x and a y. Right now, we have y. But what can we do? Well, if I know that y equals 2, why do I not go back up to this top equation? Again, I could use either of these equations, but I'd like to make my life easier. So I'm going to say, hey, from this equation right here, x equals y minus 7. And I'm going to take this 2 that I just found and saying, hey, I know now that y equals 2. So that's going to go there. And so now I have x equals 2 minus 7, 2 minus 7, which means that x equals negative 5. Now I have cause for celebration. Now I have my pair. I know what x equals, I know what y equals, and I can write it. X is negative 5, and y is 2. Happiness and joy, people. There we go, there we go. That is my solution to my system. All right, so again, each of these examples is a little bit different, and you can learn something from each one, so it is worth focusing, paying attention, seeing what happens. All right, next one up. Oh my gosh. Would you believe that the first 2 examples were nice examples? And this one is not as nice. See, if we look at this, one of my equations had y by itself. And in this one of my equations had x by itself. And you know what? That's not true here. This is a 5x minus 3y. They're on the same side. They've got coefficients. It's crazy. This is a 2x plus y. They're on the same side. I don't have any variables by itself. Guess what I have to start with? You got it. Ladies and gentlemen, right here, 2x plus y equals 2. I'm going to take this equation, and I'm going to get y by itself. Why did I pick this equation? Did I just randomly pick it out of the blue? No. I said, hey, this x has a 5, this y has got a negative 3, this x is a 2, this y just has a 1. In other words, this equation, this one's going to be the most helpful to me right now. So I'm going to just focus on this equation right here and say, all right, how can I get y by itself? How can I get the 2x to go away? Well, that's a chunk. We're going to get rid of the whole chunk. Minus 2x there, minus 2x on both sides. Solving, solving, solving. That's going to go, there's my y by itself. And 2 minus 2x, those aren't like terms, but I can just write it. 2 minus 2x. So I'm writing them next to each other, but I can't actually subtract them because they are not like terms. Okay, how is this helpful? Well, now I've got y by itself. And now I know that y equals 2 minus 2x. And there's my chunk. And I'm going to go hunting into the other equation for where I can put that chunk in place of y. Since this is the same thing as y, I'm going to put it in place of y. Alright, there's a lot going on. Pay attention. Here's the 5x. I'm just going to rewrite this equation. 5x minus 3. But again, instead of writing a y, I'm going to put this chunk in its place. I'm going to use parentheses again. So 2 minus 2x, and this still equals 38. So it's the exact same equation as this first one, except I've plugged a piece in for y. And again, just joy, continue, crank, see what you got here. Again, we've got distributive property. Watch that minus. Okay, there's a reason I put a minus in this example, because people lose it and they don't focus and then they're wrong. So this is still going to be 5x for now. This is a negative 3 times 2. That makes a negative 6 or minus 6. This is a negative 3 times a negative 2x. Negative times negative is positive or plus 6x, and this still equals 38. Again, like terms, these are both on the same side. So let's see here. 5 and 6 is 11x total. Minus 6 equals 38. Shoot, I hope I didn't do this wrong. I made my own examples for this one, so let's hope that this one isn't terrible, shall we? Alright, so what's left here for getting this by itself? Oh, you know what? I'm okay. I'm good. Plus 6, there we go. Again, working on getting the x by itself because we already made the y go away when we substituted. So 11x now equals 38 plus 6 is 44. Yep, I like that. Dividing by 11, continuing to get the x by itself. X equals 4. You know we're not done, right? You know we're not done. So again, I can go back up to any of these equations and put in x as 4 so I can find out what my y value is so that again I can have a point, an ordered pair for my solution. I'm going to go back to this guy right here because I want to find y, and this one is the easiest. So I'm going to take this guy right here. Y equals 2 minus 2x, and I'm just going to say, hey, I now know that x equals 4. I'm going to throw that right in there in place of x. So this says y is equal to 2 minus 2 times 4. That means that it's going to be y equals 2 minus 2 times 4 is 8, which means that y equals negative 6. And I have my ordered pair. My x is 4, and my y is negative 6. Again, this is the point that works in both equations. That's why it is the solution to the system. It solves both at one time. Alright, last example, and I threw this one in here because sometimes life is crazy, and I just want you to see what crazy looks like. So I already put up the caution flag here. Beware, alright? Things can happen that are weird. Now you might be looking at this one going, you know what, it's not so bad. Because, hey, look, I already have the y by itself. So here's my chunk that can go in place of y in the other equation. So I'll just plug that right in there. And you know what, that seems great, so let's do that. 4x, again, I'm writing this equation, plus 2, but in place of the y, I'm going to put negative 2x plus 9, and then that still equals 7. So rewriting that first equation without the y, substituting negative 2x plus 9 in its place. Again, because there was a coefficient of 2, we are going to distribute. So 4x is equal to, not equal to, sorry. It's a positive 2 times a negative 2, that's going to be a negative 4x. And a positive 2 times a positive 9 is a positive 18 equals 7. And these are on the same side. They're like terms. I can put them together. Oh, wait a minute. 4x minus 4x, that's gone. That means that there's no more x's. And I'm left with 18 equals 7. Last I checked, 18 did not equal 7. What does this mean? Because this is a false statement, this means that there is actually no solution. If you were to graph these two lines right here, they would never ever cross each other. And so Graphically, that means that they're parallel lines, but algebraically, this is what that would look like. You basically run yourself into a wall, and if what you're left is a false statement, then it's no solution. Now, if we got 7 equals 7, then we would actually have infinitely many solutions. So that's kind of a crazy outcome as well. All right, so basically, this is all very doable stuff, but goodness gracious, there's so much details. Don't give up. Try to pay attention, focus the best that you can, and keep practicing. All right, thanks.